Hey, Suji, I'm just a little preoccupied for a minute here.
Yeah,
Sorry.
yeah, no, no worries.
Okay, I'm back.
Yeah,
Uh, it's good to see you.
yep, same here.
Um, how's your son doing with his computer? All his computers.
Oh, yeah, I think, yeah, I did see his new computer. It's actually quite nice. It is a gaming computer with lit up keyboards and, very, yeah.
Yeah. Have you watched Dead Pixels?
Hmm?
Have
Oh,
you-
I don't know. I mean, I didn't actually see him working on
No,
it.
no. I mean, there's a TV show
Oh, okay.
called Dead Pixels.
Oh, I didn't see that. No.
It's a comedy sort of about gamers that are just
Okay, okay.
anyway, it's funny. It's outrageous, but
Yeah. Well, talking of movies, there is one I watched yesterday. It's actually like a series, but I watched all the episodes yesterday. Billion Dollar Code. It's about two guys in Germany who built something called TerraVision, which was the precursor to Google Earth, and basically how they, foolishly talked about their idea to a guy in Silicon Graphics who then joined Google and took the idea with him and implemented it.
what's it called?
Billion Dollar Code.
And did they show how they created the middle out algorithm?
Um, the middle out, I think the one you're talking about, they recursively go and focus
No,
only on
no,
any
no, no,
element.
no. Suji, it's a Silicon Valley joke.
Okay, I didn't know that. Yeah.
Sorry. Maybe I'm not saying it right, but he creates that's the whole thing. He creates um this algorithm that compresses data insanely. But anyway,
Okay.
hey, wow, we got a full house today. You got Dan here. How you doing, Dan?
Hey, Dan.
Good. How are you?
Good. We I chatted with Dan. I think a couple of weeks ago just to check in on you.
Yeah.
And
Yeah.
I think you said you did manage to land a job.
Yes. I landed a job. I've been there like 5 months now. I've been super busy. So
Cool.
figured I'd hop on and say hi.
So you're out of the oil and gas industry at this point?
Kind of, sort of. Yeah. So I'm at a Microsoft cloud consulting firm, Microsoft Gold partner. And the company's called Nudesic, and Nudesic got a Houston office, which most of our clients out of our Houston office are oil and gas clients, but we do have some diversity in there. So actually right now I'm working on a client that's in the legal space. There's more oil and gas clients on my horizon. so yes and no.
You must have just like shit your pants when oil went to negative and they were paying people to take it off their hands.
Yeah, that was after was that after I left or before I left? I don't remember. It was
no. It was after you left.
Yeah. So oil industry is crazy.
So someone was going to ask a question, I think.
Okay, no, that's it. Hi, Dan. This is the second company, right? You were going to work for some DC company, I think, right? Or is it the same one?
This is my this is the first job that I got after being unemployed.
Okay. I thought you were going to go work for some DC
had an interview.
Oh, okay.
With a company in DC, but it didn't pan out.
Okay.
Well, quickly catch us up on the type of work you're doing day to day, the nitty gritty.
Yeah, so I'm on a really interesting NLP project at the moment. So this company, this client of ours, they have patent data that streams in every day, all the new patents that get filed around the world in all sorts of different patent authorities. So there's the US Patent and Trademark Office, there's a Chinese one, a Japanese one, a European one, et cetera. There's probably dozens of different patent offices. And so when a company files a patent, let's say they file a patent in the US, they also want to protect their intellectual property in other jurisdictions. So they will file another patent in the European, the Chinese, et cetera, that all refer to the original patent. And what the client has been planning to do is they want to translate all these new patents that come in from whatever their original language is into 6 major languages. So English, German, French, Chinese, Japanese, and Korean. But that's a lot of translation cost. It's pretty expensive with the amount of documents that they have coming in. And so what I'm working on is, can we avoid translating some of these patents, knowing that basically the same thing is probably filed somewhere else in the target language that we want to translate it into? And so I'm building a Siamese network to measure document similarity based on embedding distance. So it'll generate an embedding for a field of text, and then you can compare those with cosine distance to figure out how similar those two embeddings are. And if the embeddings are close, then we can say, hey, we don't need to translate this patent. We can just say, hey, this patent already exists in the Chinese authority. You refer to that patent if you are interested in reading it in Chinese. So that's the high level ask that I'm solving. Under the hood, I'm using XLM Roberta from Hugging Face, pre-trained. So that's a multilingual version of Roberta. And so I can feed it in text fields in any language, any characters, and it'll output an embedding for that. And so I've been using, to this point, I've been using the pooler output for sequence classification as my embedding, and then training a custom model on top of that. But I don't think it has enough information in that pooler output embedding to be able to get the type of performance that we need to get. So my next step is to actually train using the full input sequence or the full output sequence for the embeddings for each position, for each token, and use that as my input to my custom model. And I'm planning to do another transformer layer on top of that. I have 2 different directions I'm considering going. One is retraining, fine-tuning the entire transformer architecture. And the other is just building a short little transformer on top of freezing the XLM Roberta, and then putting a short little transformer, 1-layer transformer on top of it as a fine-tuning, so that it'll have fewer parameters to tune. And it should go a little quicker. Yeah, those are my 2 options that I'm considering next. So it's an interesting problem. I am starting to get into the area where I need to do distributed training. So at the moment, I'm learning Horovod to do multi-GPU training, which is very difficult, I'm finding. So yeah, lot there. I just talked for a long time, but that's what I've got going on.
The Siamese bit is basically you're taking the output from the CLS output from both of these inputs passing through Robota, and then you're training the Siamese network, right?
Yes, that's correct. Yeah.
Okay, right. Okay.
Mm-hmm.
Could this basically be considered a cross-language deduplication problem? Or did I miss something?
I think that's what it is. Yeah.
Yeah.
So, this may sound stupid and simplified because what you're doing sounds like it probably will work a lot better. But you know, we've talked about this a lot, right, CG? There's the vector databases, vector search engines. The one there's Vespa, but there's one called Pinecone. You know, Pinecone on a tree. Have you heard of that?
Yeah.
I mean, Dan, have you heard of Pinecone or Vespa?
I've heard of Vespa. I have not heard of Pinecone.
So Pinecone's a managed service. It's like Vespa. It's very easy to use at fairly smaller scales. It's inexpensive, but the point is you can use any embeddings you want. And there's a bunch of different indexing techniques, and it's extremely fast. And you can do similarity. And actually, one of their use cases is deduping. And you actually you put any embeddings you want into it. So, Suji, what do you think about using Pinecone or Vespa for deduping as opposed to this Siamese network approach? What are your thoughts? Cross-language deduping.
I think Siamese network is actually pushing it. You know, so it's kind of encoding the application's idea of similarity, right? So if you have a patent in English, and you know whether a patent in Chinese, which is identical to the patent in English, if that is the one that qualifies, or if it's something similar, right? So it becomes more of a binary decision, right? Whereas with the vector thing, it's more of a, you know, it's a number between 1 and 0. So you have to figure out what the threshold is yourself, I think.
How about LSH, which we've talked about, local semantic hashing for deduping?
Yeah, LSH could work, I think, also. But again, across languages, that, yeah, I guess it could. Yeah, you could cut it off.
So one of the advantages that I have is that we do have the metadata that says what the patents cite, so what the original patent is. So I don't have to go searching through the entire corpus to look for potentially similar patents. There's only a handful of patents. So like if I've got
I get it.
English
You could
patent,
you're subsetting your space by the metadata, so you're not dealing with the entire collection of patents.
Yep. So the complication is like, so just because one patent cites another patent doesn't necessarily mean that all of the text fields line up. So like there's a patent has a number of claims in it. And so there may be one, when it's filed in the US, this patent might have 12 claims. And then when it's filed in China, there might be an additional 3 or 4 claims. So it might be like 15 claims. And then trying to figure out, okay, which of these claims are new for the Chinese patent? Which ones line up with the English? How do those map to each other? That is one of the main use cases for this model. So it's not like searching through millions of documents, it's searching through maybe a dozen, something like that.
Yeah, that's nice.
Yeah.
And have you had luck? I mean, have you had reasonable luck with the output?
So I've gotten to, so I've run it on a few of the fields, the titles, the abstracts. The titles and the abstracts have tended to be very similar, and I have seen some indication that the model is learning something and it's giving some benefit. But for titles and abstracts, most of the just knowing that one patent cites another is usually pretty close to good enough. We can get about 90% accuracy just using that alone without any machine learning. And then adding the machine learning on top will add a little bit of improvement. With the claims, I'm seeing more evidence that the model's learning something, but the performance isn't great. I'm getting about 60% performance at the top end of the claims data, and it drops off pretty heavily as you get to lower similarities. That's why I want to go to the additional bigger model.
So the citations are if one patent cites the other across language, that's high probability that they're.
Yeah, well, it's not just citations. It's there's something called a patent priority document. So when you file a document, you need to say, okay, the priority for this document is X other document filed in other X, Y other jurisdiction. So those priority connections are how we.
Yeah. You're prioritizing for the person who's making the decision. Look at this first. This country said it was good.
Yeah. So from a legal standpoint, it's saying I have the right to claim this intellectual property because I first filed it in the United States on this date. Therefore, I can now file it 2 months later in Europe.
Yep. Yeah. Okay.
Actually, I'm curious. What's your XLM Roberta output right now?
Yeah, so it outputs a 768 dimensional embedding for each token in the input sequence. And to this point, all I've been doing is taking the CLS tokens embedding and throwing away the other 511 embeddings. But my next step is to take in all 512 embeddings and see if I can improve the model performance using that, which I think should help a lot. But it's
CLS the beginning of string, or? Yeah, that CLS because CLS gets influenced by the phrase itself.
Yep. Yeah, that's the sequence classification token. Yeah. Okay. So yeah, has anybody have much experience with distributed multi-GPU training? Anybody have any preferred methods of doing it?
There is a data parallel. I think PyTorch has that.
Yes,
and
so
that's native.
I've been learning up on distributed data parallel, and it is not just a one-line change.
No, it's not. No. Yeah.
It's pretty involved. Yeah.
Are you talking about splitting up, training different parts of the model on different GPUs and bringing it together? Is that the type of distributed?
So my model does all fit on a single GPU. So I'm splitting up just the data. So I'm splitting up the batches. So I can fit about 4. I think I can fit a batch size of 4 through my entire model on one GPU with the RAM I've got. But I'd like to get more throughput than that. So if I can train it on 8 GPUs, then I can get a batch size of 32. That's what I'm shooting for.
Does that mean, so fundamentally you want to speed up the training process?
Yes.
And does that mean that, so you have the whole model on each GPU and you're training them separately and then you somehow bring them together? Is that what?
Yep.
Okay. And I don't think RayTune does any of that. Does it, CG?
Sure.
You're not sure? Because RayTune's a great tool for distributed machine learning. You've heard of Ray? Not RayTune, but Ray.
Ray, yeah.
That project, Dan?
Yeah, I've heard of it. I haven't used it. I've seen it. So I've been looking through different. I think where did I see that come up? I think as I was looking through the Horavad documentation. Yes, Horavad on Ray.
So RayTune, yeah. So RayTune's a great thing because it does a lot of RayTune is the tuning part of it, and it does this distributed experimentation, which is exactly what you want to do, distributed hyperparameter tuning. And it uses, like, I used it when I tried it out. It wasn't for really doing distributed, but what it was also is like this meta framework. So basically for optimization. So like when you're doing experiments and you want to optimize, like do a Bayesian optimization of the parameter space. So instead of having to do, 1,000 experiments, you can do, like 5, and it gets right to very close to the optimum, right? So I was able, it was like 8 different libraries or 10 different libraries for optimizing hyperparameter tuning. So that's why you probably saw Horovat on there too, because it's sort of this way of bringing in these. So it probably has multiple ways of doing what you're interested in. But anyway, and it's also very usable, I think. But I don't have a lot of experience with it, so I'm gonna post right here, just so I'm sure you know of it, but.
Yeah, so my client, their main environment is in Databricks. And so I'm trying to figure out how to, Databricks is not fun, but
halfway between Hadoop and transformers in the ideology of machine learning.
Yeah, so trying to figure out how to get the distributed data parallel to work on Databricks when I don't think I have access to the command line in Databricks. So that makes it more difficult. Everything has to be run through a notebook, which is unfortunate.
You can do bang, and then if that works, I don't know. Bang and then a shell command.
Yeah, but so like, so what I got pretty far down the path of PyTorch Lightning has some built-in stuff to make distributed a lot easier. But the way that it does it is that it will automatically run it launches new scripts from the command line, but it can't do that from within the Bricks notebook. So, because it has to have access to the environment variables and all sorts of other stuff that it doesn't have.
They won't give you access to the command line, on a cluster. Not through Databricks, but just a GPU cluster.
Yeah, they don't. They only have clusters within Databricks. So yeah.
There is, was it Yahoo? There is a distributed thing on Databricks for.
So I know. So there is Horavad for Databricks, but there's not a lot of documentation.
Okay. Yeah.
So I know it will work, but trying to figure out how to make it work is.
Okay. Yeah. I saw a demo at one point. I think.
Yeah.
Guys. So yeah.
Mm-hmm. It's amazing how much documentation matters.
Yeah.
Proper documentation. This could probably be super easy.
Yes.
I think so I haven't done it myself, but I was told that you can run scripts on Databricks, so the code doesn't need to live in
a notebook.
In the notebook, but I haven't done it. I haven't done it myself.
All right, guys. Anything else on distributed?
Actually, funny thing is, I need to like run something at scale in the next week, and then like further out, and I have a choice between pure AWS, like my own machine, which we have like environment to create, or go learn Databricks because we have Databricks now. So I may know more about it on Monday.
Cool.
Is this your satellite data?
No, it's like I don't know. I keep my projects keep getting over prioritized, like by more urgent projects. This is actually it's a similarity project also, but similarity between agricultural land, which actually somebody wanted to build it as a vector, but we haven't done that yet. But right now it's just a different combination of different distance measures. Yeah. But it's you know, we look at the whole world, so it's a massive amount of data that we pull, and I know I need to like run it for like a bunch of scenarios, so I need to like, you know, think of how to like quickly scale it, and it's I can actually do both notebook and you know, real code.
So it's more of a structured data similarity problem at this point.
Yeah, time series similarity actually, mostly.
Time series, okay.
Because, you know, everything in agriculture, everything is, you know, yearly cycle, weather.
And grow, and things grow. Okay. Is there anything else you want to bring up, Dan?
I just want to hear how everybody else is doing, what's new, the updates.
Well, I'm going to give you a quick update. I continue to progress with my, I guess, my similarity engine at work. I'm doing a lot of similarity stuff, but it's semantics. So I've done this Word2Vec semantic similarity space where you can enter it with a keyword or a topic from our taxonomy or a product taxonomy or a document. All those things are in the same semantic space. And you can query on one and get the others out. And I've got my bird on my shoulder talking with me. But I actually, that's beginning to move. It's like a POC. A lot of people in the company are very excited about it. It has many applications. It's already in production for sort of a kind of half-assed classification application that we needed to classify web pages. And so it's really beginning to sort of catch fire internally. And there's a lot of things happening. So I'm progressing very well with that stuff. And really, I believe from this, in a way, I would say, you know, similarity it's almost like a killer app in an enterprise, especially, you know, I mean, we're pretty small. We're like, you know, under 1,000 people, and we're also sort of a publishing company to some extent, but it's just amazing how many applications there are in a normal company, you know, not like a software company, right? We're really a marketing company. Mm-hmm. Yeah, I'm amazed at the power of the similarity engine at a company like us.
Yeah, any sort of the realization that I had is that any time where you have a classification task with a large number of classes, similarity is going to be very helpful. So that comes up all the time.
Yeah. So what do you mean by that? Just because it's easier to implement than the huge taxonomy?
Yeah. Yeah.
So I'm kind of stuck with that right now. I'm going to have to face it because we didn't plan to use it for that. We're using it for that. But it's not as good as we need for certain things, right? So like it was very successful as one thing, probably because the data is not as visible. So we would also greatly benefit from a traditional classifier, you know, for our 5,000 topic taxonomy. And we do have the training data for it. It's just that it's multi-label. We need multi-label, and it's so many topics that it's going to take a long time. It's more like a very traditional data science project where it takes you 6 months to, you know, to get anywhere with it and to really focus on it, you know, and I don't have a team. So I'm kind of stuck in a way between a rock and a hard place with that. Already I've missed an opportunity because the current similarity-based classifier wasn't good enough for something we needed to do. And now there's another one just came up right at the beginning of this meeting with my boss that we'll try to use it for. We'll see, but yeah, it's tough. But that's why I did it, Dan. You're right. That's why I worked out that way, because similarity is much. It's almost like extreme classification, right? That's the not extreme classification, but zero shot or one few shot.
Yeah.
Few shot's another solution, and I've tried to use it sometimes. But I mean, part of the problem, I don't think you can really use it for a large taxonomy, right? Because at least the way I've seen few shot, each topic is the question. Right? Is this, like for few shot, you go, or one shot or zero shot or whatever, you go, is this document, this is zero shot, is this document about software-defined networks, right? That's how you do the few shot, or the zero shot with the transformers, at least the one I used, right? So you'd have to ask 5,000 questions for each document, each time. So it's not scary.
Yeah, so the use case that I've usually seen presented first in training classes and stuff is facial detection, right? Where you say, okay, is this picture the same person as this other picture? And you only need maybe one other picture or none to be able to have as your training data if you've trained on enough pairs of pictures.
Yeah, so it's a binary, classifier, but basically. So if I had two classes and I had to run that against all my content, that would be easy. So, yeah. Anyway, all right. Well, I'll continue to on that space as we move forward.
No, this is kind of a deep question too. Yeah, unsupervised. And you basically go with this: are these two pictures similar? Are these two pictures different? And you have enough pairs, you can do contrastive learning, and then you create like a binary. You're able to split you're able to cluster based on that, right? And then you could use those clusters and come up with something more, like as input to your labels, and then you go into supervised territory.
Yep. Yeah, it's amazing what you can do with those embeddings. So many possibilities.
Yeah, so you're saying subset it first. That's the real. It's kind of like what you're doing, Dan. You're subsetting on the metadata, right? All right. Does anyone have anything else they want to bring up or discuss?
Well, no, not really. I mean, to bring you up to speed, then I'm now doing an engineering role almost. So we got moved into different groups, right? And as like as a part of a team, right? So the objective is that I learn the problems and try to offer solutions. So I'm doing mostly that, although I'm doing this role as part of multiple teams now. So it's like I'm doing something here and other things and other places. So it's more of, so my task has been to basically ingest documents. Lately, a lot of firefighting. So that's there. But on the flip side, I've also been able to move forward. One aspect of my previous role was that, as a central group, I don't get access easily to other people's data, right? Even within the company. So you have to like beg and, do a lot of other stuff to get access. But now that I'm in this team, I have access to all of the data within this team. So that has actually helped me a little. So one of the things I've been advocating for is that a text annotation pipeline that we have currently, but which depends on some old technology that we have. And the technology is basically based on query parsing, right? So the idea is that as you enter a query, you parse it and you extract concepts out of it that match up with your taxonomy. And so the current text mapping is also the same, uses the same backend. So, but there is a difference because with QP, with query parsing, it can take tokens which are not necessarily consecutive and join them up in innovative ways so that it can match the taxonomy. So it kind of forces. So let's say I have, let's see, Cancer Hospitals, Minnesota, right? And assuming that Hospitals Minnesota is a concept, right? Cancer Hospital. So Cancer Hospitals Minnesota. Well, not a good idea, not a good one. Hospital Minnesota Cancer. Let's say this is the query. But I'm really looking for cancer hospitals in Minnesota, right? So the tokens can get rearranged. And assume my taxonomy has a thing that, a cancer hospital, the term cancer hospital, and Minnesota, right? So my first query wouldn't have matched any of my, well, it would have matched the hospital, but nothing else. Or sorry, Minnesota, nothing else. But with this trying to combine tokens in different ways, I would be able to match. So this works very well for queries, but we also put the same thing in for doing text mapping. Now with text mapping, because the length, the number of tokens are much larger, this is a huge computational job, right? To do this, jumble up all the tokens and try to find things that work. So, and because of that, it's really slow. So I basically advocated using Aho-Koresic or Spacey Phrase Matcher. Ultimately, I ended up using Aho-Koresic because Spacey Phrase Matcher did not, it did not have the necessary things I needed. So one of the things I needed was abbreviations. So I want to match everything case insensitive except for abbreviations. So Phrase Matcher doesn't offer me that facility, but I can change the text a little bit to basically make it work with Aho-Koresic, and that's what I did ultimately. So anyway, so that was my most recent one.
What is it called? The alternative to Phrase Matcher?
That's the Aho-Koresic algorithm, and there is a package called Pi-Aho-Koresic. Okay, I can type that in actually.
That's the lexical, that's the efficient lexical matcher.
Yes.
It uses tries. I actually have that in production, thanks to Suji. It's a great way to put a lexical matcher into production just because it's efficient, right?
Right. So I recently did that. And,
it has the worst name to spell ever.
Yeah. It's two people, Aho and Koresic. Aho is the Aho Ullman guy, the compiler book. Yeah, and the large data mining book. What was that?
That's
mining large data sets.
So
he actually taught that course, and he is the most uninspiring, teacher voice I've ever heard, or ever attended. Like he just drones on and on, but obviously he's a genius, right? I mean,
so, Suji, where are you heading with this? So I understand you're embedded in a group, so you see how they're doing things. So you're saying they need to do this matching of phrases into the taxonomy for full documents. So am I sort of getting what you're saying?
Yes. So they already have this technology, but it takes a long time to do, right? So approximately each document takes anywhere between 20 to 50 seconds. And so it's a long process, right? So we get around this by basically, spanning multiple, it's a parallelizable thing, very easily parallelizable. So you run it on multiple machines and you get it down to a reasonable time. But there are two problems with this. One problem is that, because of this, matching trying to match non-consecutive tokens, you sometimes have false positives. So that is, basically noise, right? The second one is that because of this token matching, you cannot report offsets because you don't know which one, right? So if you matched up the 7th and the 9th token to create this pseudo token that you're matching in taxonomy, what is your offset, right? Is it the 7th one? Is it the 9th one? Is it like the min and max, spans the whole thing? So there is no clear way to do it, no good way to do it, in fact. So, we don't report offsets on that. And for downstream things that depend on this annotation, let's say you're doing dependency parsing or relation extraction, you really need the offset. So that's becoming a problem now that we are trying to get to these things. So that is the basic.
So I mean, I know you're talking, it's really an entity linking or an entity extraction problem, right?
Rule-based though, because it's all taxonomies, patterns, right? It's all.
Yeah, so it's lexical. It's a lexical
yes.
linking problem, and it's being actually done in a sort of a crude way, right?
Mm-hmm. Yes.
I don't mean that necessarily negatively, but can you brainstorm it in a bigger sense? Like if you were doing this entity linking to your custom entity list or lexicon or tag, let's just call it a lexicon, right? Because that could be almost same.
Yes.
If you were doing that, you were brought in as a consultant to do it from scratch, greenfield. How would you approach that for these guys?
Basically, send it through like the Ahokorasic thing I was talking about. So the premise is here that when people write documents, they pay attention to the structure of the things, and location is actually it's important here, right? So the location of your token actually means something in text, whereas it may not mean the same thing in queries.
So right. So you're saying the Pi-Ho-Corsic, you would have the variance be all the different permutations.
No, there is no
lexical term.
So in my Ahokorasic data structure, I'm putting in all my concepts and their synonyms. So because it's in medical concepts, they typically tend to have a lot of synonyms. So you would have the common name, the medical name, and so forth, right?
Yeah. So you don't need the permutation stuff.
I don't need permutations caused by token jumbling. Yes.
So you're moving them from some permutation approach to a more sort of standard lexical matching.
Yes. I'm trying to. I mean, it still has to be. So I built a Streamlit app basically to show them this. Side by side.
Dude, we're gonna have to start paying Streamlit. Jesus Christ, those guys have been at the center of everything I've been able to accomplish.
Yeah.
People do not, especially in my organization, right? They're all marketing people. I mean, where half of us are just using spreadsheets for everything, But probably up. Anyway, go ahead.
So I basically have them like it's the same app, but I put up two things side by side, two browser windows, and run the same query, and it gives me a map at the end of it, right? It basically tells me what are the concepts it found and what are the frequencies. And the idea is that now I need to match up. I'll take about 10 or 20 documents and basically match them up manually and create some kind of goal set so that we can now, or at least the beginnings of a goal set. I'm not a domain expert, obviously, but using that, I create a metric. I'm thinking precision recall F-score, and basically say that one is better than the other, or how much we are losing, right? And because there's also the concept of time, the question of time, right? So 20 seconds for one versus 0.2 seconds for another, right? So there is that. Yeah. So yeah,
makes perfect sense. Yeah. Right. That's funny. You're doing it kind of parallel in different groups like that. I mean, in terms of trying to bring them up to speed. So.
Right. Well, it's a cell, right? I mean, this is something that has been working. People don't like it. There is problems with it, but it's working. So it's that.
Very interesting. Was there anything else you wanted to bring up, Suji?
No, this is it. Yeah, I don't have anything else.
Anyone else? Yuri, you got anything?
No, I saw that you listened to some NLP Summit lectures. I tried listening to a few, but like I didn't have much time. But there were a couple of interesting ones. I don't know. I'll probably will try to listen to recordings.
Yeah, they've been doing good work. The John Snow guys, at least in the medical side, they have tons of models which are. I think it's open source and their platform is open source, except for some of the models they don't share. and I don't think they give you support, but that's about it. It's Spark based for people who want to use Spark. So, you know.
Yeah. That's how I start. I got introduced because I was trying to use Spark to do tokenization at scale, and then it was a long time ago, right? And then I saw that this John Snow Labs built on top of the ML built on top of Spark. So, but actually, the conference wasn't really focused on John Snow stuff as much. It really has become a much broader, just sort of NLP in general, although it has a healthcare focus sometimes. So one of the things I found interesting, for me at least, was this. I posted it in our Slack, which was this. I'm looking at it right here. The TLDR. I had never heard of that before. I bet, Suji, you know what TLDR is?
Yeah, it's like a one sentence thing. Too long, don't read.
Yeah, it's a one sentence summary, right?
Right.
Yeah, I always think of it as a semantic signaling, where you go from, you've got a whole document, but then you could have an abstract, right? That's just semantic condensation. And then a title, really. These are all just like topics, right? And a title is a semantic condensation, not always, but a lot of times.
Did you know that you can use TLDR as a flag for GPT-3 to output the summary?
Okay.
For summarization.
Oh, that's interesting. That's great.
Yeah.
So this is the opposite of that. It's in the Slack if you want to see it. I posted it, but this is what did she do? They trained a network to produce. They wanted to train a network to produce single sentence summarizations.
TLDRs of the thing.
Yeah.
So I think it's exactly the same, right?
Yeah.
You
do in GPT-3. You feed it a long piece of text, and then your last token is TLDR, and then it will try and complete that sequence by outputting the summarization. It's learned to do that because TLDR is such a common phrase in Reddit and other places in all of its input data.
So what you're doing though is you're leveraging the existing TLDRs, right? Information. In GPT-3 to produce a paragraph summary, right?
Yep.
So now, Yuri, this is the opposite in the sense and they use BART, the BART summarization model with transformers, with Hugging Face. And what they're actually doing is taking as much of a document as they can, and they're having it generate a TLDR. Okay, so you're creating this hugely condensed summary, right? Because you're summarizing the entire document to one sentence, to a TLDR. Right?
Yeah, that's probably GPT-3 probably doesn't have enough. Probably couldn't go back that far in the sequence to do an entire document, but
no, I don't know if she necessarily has to. I don't know whatever BART's limits are, right? But her training it's a supervised approach because you have TLDR, so you train the BART. I think she's training it.
Yeah, it's just an explicit task versus the GPT-3 learns it kind of by accident.
Yeah, so hers is a supervised task. But the thing that was interesting to me is that we have a use case at work here with, we have an editorial, we have, a couple 100,000 documents. Hold on. Come here. Written by editors, right? So in that sense, we're a publisher, and we have a huge publishing network of interlinked editorial that we're trying to SEO and so forth. And one of our jobs in doing that is one thing that I learned the editors have to do is when you're writing, and it's hard to train the editors to do this, you want them to write their article, but then you want them to link using natural inline text to other editorial in our network, right? Other documents. So you're doing this in context, inline linking to documents. And so what I'd like to do is suggest, I'd like to have an annotation, kind of like editor looking thing. I mean, this is just in my mind. I don't know. I'd probably never be able to get to it, but where they, as they're writing or when they're done writing, you have it like in, one of those annotation tools, millions of amazing ones that are coming out now, right? And have it highlight possible things to link, phrases, right? Little spans or entities or whatever, and then suggest documents in our network to link to. I don't know if you guys are following me so far, but you could also then do extreme summarization for each one of those 10 suggested documents and produce, it would have to be not really a full TLDR, but actually I'd want to even make it shorter. So that would suggest, short phrases that they could reword.
Like a title.
Yeah, they could, well, you don't use the title. It's like you've got your paragraphs in front of you, you've written, you have an identified span or something, and maybe you could rewrite that to that extreme summarized whatever. Do you sort of get what I'm getting at? Because it's evidently it's a cognitive burden to look at your text and say, here's a document I want to include in my text, here's its title, how do I put that into my text, embedded in a way that's natural? I'm trying to resolve that cognitive pain. And I'm thinking, that's why that was interesting, because it's extreme classification where you're reducing the shit out of the ultimate classification is, extreme summarization is classification, right?
Yep.
But that's as close to it as you can get. So it'd be like span summarization. And then there's TLDR summarization. And then there's paragraph summarization. So you've got this. Anyway, I just let you guys know the way I'm thinking about it, but why it was interesting to me. So that was one thing, Yuri, that going to that summit did. I really didn't attend much. I did some live. I looked at a little bit, like randomly between my work, and I happened to come across that one, and it just sparked off that whole train of thought in general.
Yeah, I saw your thing, and I read the paper, the extreme summarization paper.
Yeah.
So yeah, it looks interesting. Yeah, and we should be looking at summarization. I actually suggested it that we create a lot of content using human experts, not necessarily doctors, but summarizing books and for easy reading, books and groups of articles for easy reading. So this is something that we should probably invest in to do automatically, and if we can get it to do automatically, we can, increase our volume a lot more. So, yeah.
Yeah, there's a lot of ways NLP can assist in the editorial process.
Right, yeah.
For sure. I had one other thing I just wanted to ask about. So I've been reading just a teeny bit about MUM. You guys know what Google MUM is?
I don't know. Yeah.
Ooh,
no.
It's a huge, big deal. Yeah. Dan, have you heard of it?
No, I haven't.
So it's multitask unified model, MUM. And from the marketing and SEO point of view, it's the biggest thing. Basically, Google, it's multimodal.
Okay.
So it's a multimodal form of search, but it's also sort of a dialogue system, and they're beginning to integrate it into their search results. And it's like sort of they've gone from this world of keyword to complex concepts, and the idea is that it's going to help enable doing one query after, like guided querying sort of too. But and it's sort of, anyway, they started using BERT, and this is in their models. And so from an SEO point of view, what people are talking about in the marketing world is you're going from keyword SEO, and then in BERT, you started going more towards semantic SEO. And now with MUM, you have to do more semantic and entity SEO. But why I was asking about it in this group is because I was wondering if anyone understood the technology behind it. It's evidently uses multiple models and things like that.
It looks like it creates like a thought bubble kind of thing, right? Like a graph. I'm just searched up multi.
Yeah, so
NLM,
you think it's a
what you
dialogue.
said.
Part of it's like a dialogue system that uses a graph of information. Is
Right.
that, yeah. Mum. Anyway, I'll post it here too. Oh, we both did the same thing, which I didn't even see yours.
No, I didn't.
Yeah.
Yuri posted, right? Yeah. Okay.
Yeah. Thanks, Yuri. Also, let's see. I wanted to ask about. Oh yeah, Sujit, I saw your thing with the data QA.
Yeah.
Now I looked at it, and I also looked at the Odinson, and I totally get the Odinson. That's pretty cool.
Yeah, it is.
It's that pattern search for facts and relationships, right? So you could on the fly search tell me if I got this right. You could on the fly search like a search engine on a collection of content.
Exactly. Yeah.
Use pattern, sort of like syntactic pattern matching. That's one of the ways, at least.
Yeah, you can also do things like part of speech, right? You can say, this followed by a verb, some word followed by a verb, right? And this is the pattern we're looking for.
Yeah, I mean, it's kind of like the grammar rules on the fly.
Right.
When I think about the grammar, the matching and spacing you could do on
right.
And I looked at
this is Odinson?
Odinson, yes.
Oh yeah, here I'll
Oh no, I'm looking at it. Yeah.
Yes.
So this is something I think is a cool idea, that adding the search engine by default, because usually when I'm doing rule generation from text, right, I typically end up doing tons of greps and looking for patterns, but I have missed having a search engine, but too lazy to build one, right? But the fact that it gives it to you, and I would actually love to have an Odinson style search engine, and so I can put in these queries almost like how the regex buddy is, right, on online regex, right? It's almost like that, right? You basically put in a rule and see what comes back, and that becomes the basis of creating, like it's like a what's that called, tool bench, or it's kind of like interactively you can create rules and see how good or how bad they are, right? So
you can create right. It's for rule testing. It's for like grammar rule testing.
Yes. So let's say you want to say, you are trying to find, say, toxic molecules, right? And you want to find sentences that indicate toxicity. So you could come up with some thing that says, anything that has toxic in it, that's sentence, right? So you look for toxic, then you say, okay, toxic and all its stems maybe, and you kind of, and then you can do part of speech, like you have a molecule entity followed by the verb, some kind of verb that indicates toxicity, right? So that sort of thing we can.
I totally get it. If you're a lexicologist or doing grammar rules, right, of sorts.
Right, exactly.
This is your tool.
Right.
Like
but even for Snorkel, right? Because you have to create these labeling rules.
Oh yeah. You're right.
So that was my application basically. Yeah.
Which is why you brought it up within the context of that particular annotation tool, right? Because it's a rules-based annotation tool. And so the idea is to be able to not just have a search engine, but have Odinson or something like that. That makes sense. That's a great idea.
Yeah, I want to explore this idea a little bit. Usually, since most of my data is all medical, it's kind of hard to play domain expert because it's not, I cannot fake it as a domain expert. But it takes some. I want to take some, simpler data set, right, or more mainstream data set where I can play domain expert and try this out.
Yeah, I get it. That's cool. Because I saw you post that. I read about those things real quickly because I wanted to fully understand what your context and what your thinking about it was. That makes perfect sense. That's pretty cool. Okay. Anyone have anything else? All right, guys. Well, it's good to hear from you, Dan. And
Yeah.
Feel free to drop in. Even if you can only come for 10 minutes at the beginning, we'll focus on you or something, whatever you want. You can just drop off. I know it's a long.
Yeah, I'll hop in from time to time.
It's a long time for someone that has how many kids you have now?
4.
Kids, dude, young kids.
Yep. Yeah.
All right, guys. Talk to y'all later.
All right. See ya.
Thank you.
Thanks.
Bye.
Bye.